Some students have a little trouble with angular velocity, so we're going to take a look at some of these problems just for practice. And we'll talk about what we need. Make sure that you have your formulas pulled up. The first formula that we have is actually for angular velocity in general, and it is the symbol for angular velocity is omega. It looks like a W, equals the angle in radians over time. So let's look at this problem. It says Kim and Nicole are riding on a Ferris wheel. It takes 20 seconds to make a complete revolution. Now, when they talk about anything going around a circle and the time that it takes to do it, they have actually given you angular velocity. So what they've really given us, if we think about this, is they've given us this circle, this Ferris wheel, and they're telling us that it takes, like if this were my seat, they're saying that it takes me 20 seconds to go all the way around that circle. That's what it's telling me, because that's one complete revolution. And in this one, they're saying their seat is 25 feet from the axle of the wheel. So here's the axle, an axle is in the middle, and this is 25 feet. So they've actually given us the radius of that circle. That's what we have. And it says, what is their angular velocity in revolutions per minute? And anytime they're talking about going around that circle, whether it's the radians per minute, revolutions per minute, whatever, if it's talking about going around that circle, that is angular velocity. So when we look at this, they're telling us that we're going around that circle one revolution, and it's taken us 20 seconds. And they are asking for revolutions per minute. So we can do this one pretty easily in that we already have revolutions and we need it to be in minutes, and we know that there are 60 seconds in 1 minute, and this is dimensional analysis. If you have the seconds on the bottom and you want to make seconds go away, if you put seconds on the top of a fraction, you can make those two cancel. And so now we would just need to do the math. And so we have left, the word that we have left, or the abbreviations, we have revolutions on the top, we have minutes on the bottom. So we have 1 times 60 is 60 divided by 20 times 1 is 20. So 20 goes into 60 3 times. So for this we have 3 revolutions per minute. So we've answered that question on this one. The second question says, what is their angular velocity in degrees per minute? So we have our answer in revolutions per minute. So we have revolutions and we have it per minute. So we need to think about that for just a minute. 1 revolution going around that circle, you think about how many degrees that would be. And that would be 360 degrees. So 1 revolution is 360 degrees, and it's per minute. So if I do the 3 times the 360, I will have 1080 degrees per minute. So that one was fairly simple. That one was a little easier to do. Now this one says, what is their angular velocity in radians per minute? So we know from a previous set of problems that we had how to change degrees to radians. And what we do is we multiply by pi over 180. So when I do that, I can cancel 1080 divided by 180 comes out to 6. So this would be 6 pi radians per minute. So this is in radians. So that's what that one would be. So we can take this one, and it says, what is the linear velocity in feet per minute? We have a formula for linear velocity. It's radius times the angular velocity. And we have angular velocity right here. We have it in several different forms. So we know the radius is 25 feet. And we have the angular velocity is 6 pi radians per minute. and they want this in feet per minute. So we actually have this in feet per minute. So we already have feet, we already have minutes. 25 times 6 is 150. It says leave it in terms of pi, so this would be 150 pi feet per minute. And that gives us our linear velocity. So this one says a flywheel rotates with an angular velocity of 2 revolutions per second. It says find the linear velocity if the radius is 15 inches. Write your answer in feet per minute and round to the nearest hundredth. Remember that anytime we're given something about revolutions and time, they have actually given us angular velocity. So they've given us the angular velocity. And we know that 2 revolutions, 1 revolution around the circle is 2 pi, and 2 revolutions around the circle would be 4 pi radians. So it's 4 pi radians for 1 second. And this one wants us to find the linear velocity, and your formula for linear velocity is r radius times omega angular velocity, and it wants to give it to us in feet per minute. So I could go over here and let's just go ahead and do some simple conversions here a minute. They give us 15 inches, and we know that 12 inches is 1 foot. So 15 divided by 12 is 1.25 feet. So we can go over here and we can say that the radius is 1.25 feet. And we know that the angular velocity is 4 pi per second. Now we don't want it in seconds. They want us to give it in feet per minute. We already have feet. So we know that 60 seconds is 1 minute. So that make the seconds cancel. And I'm left with feet, and I'm left with minute. So 1.25 times 4 pi times 60, and I'm going to go ahead and round so that I get 942.48 feet per minute. It says round to the nearest hundredth. So I've got an answer that is now in feet per minute. Now let's take a look at this one. This one says a bicycle with 24-inch diameter wheels is traveling at 15 miles per hour. Find the angular speed of the wheels in radians per minute. How many revolutions per minute do the wheels make? So what we have, let's see what we have first. We have a wheel, I just love my circle there, with a 24-inch diameter, which means that that wheel has a 12-inch radius. And we have a few formulas that we can use. We have angular velocity, we know is radians over time. And we know that linear velocity, one of the formulas that we have is s over t. And they've given us linear velocity. They've told us that it is 15 miles per hour. So if you match this up, they've told us s, which is 15 miles, and they've told us the time, which is an hour. So 15 miles per hour. We also have, one of our formulas is s is equal to radius times theta. So if I wanted to get theta, which is the angle measure, the distance around, I could get that by itself, and I could do s over r is equal to theta. And I've got s, which is 15 miles, and I've got radius, which is 12 inches. So if I do a little math here of all the things that I have, I know that 1 mile is equal to 5,280 feet, and that 1 foot is equal to 12 inches. So if I do the math that I have here, I'll just extend this page. I just put it in my calculator. I get the inches cancel, feet cancels, miles cancel, and what I'm left with is this radian measure, this angular measure. And so when I do this on my calculator, I get 7,900. And that's in radians. When all the units cancel out, remember from your video that means that it's in radians. And so the time of this is in 1 hour. And remember that when we're looking for angular velocity, if we have the radians over time, we have angular velocity. So we have radians over time, so we actually have the angular velocity, and we want that. Let's see, how does that problem say that we want it? We want that in radians per minute. We have radians. We know that 1 hour is equal to 60 minutes. Hour cancels, so let's see. If we take 79,200 and divide that by 60, we get 1320 radians per minute. So this is what they've asked for. Let's see what the next thing is. The next thing says, how many revolutions per minute do the wheels make? And so we need to think about that for a minute, about radians. So for this one, you know, a radian, if you think about that, if I go around, let's think about what we're doing here. 1 revolution all the way around is 2 pi radians. So 2 pi radians, if I wanted that to cancel out, is 1 revolution. So the units for radians cancel out. 1320 divided by 2 pi, and 2 pi is roughly 6.28, comes out to 210.19. So that is 210.19 revolutions per minute. So the trick to these problems is to make sure that whatever they've given you, you look through and you say, okay, what did they give me? Which formula does that fit? How can I manipulate these formulas to get what they're asking?